Let's understand various components of Azure Application Gateway and how it works. Azure Application Gateway operates through a series of key components that work together to handle incoming traffic, route it securely, and load balance it across a group of web servers. Let's discuss various main components and its role. First one is front-end IP address. Front-end IP address is the entry point for incoming request. The application gateway receives client traffic through a designated front-end IP address, which can either be public, private, or both. Note that each application gateway can only have one public IP address and one private IP address at a time. This makes it versatile for internal or external applications. Next component of application gateway is listener. Listeners are responsible for listening to incoming traffic on a specific IP address, protocol like HTTP or HTTPS, and port. A basic listener routes requests simply based on the URL path. A multi-site listener can route requests based on both the path and the host name, which is especially useful for multi-tenant applications. Listeners also handle TLS SSL certificates and ensure encrypted communication between the user and the application gateway. Each listener is tied to specific routing rules to determine which backend server should handle the traffic. Another component of application gateways is routing rules. Routing rules act as the decision makers and link listeners with the backend pools. A routing rule interprets elements like the hostname and path in a request URL to direct traffic to the appropriate server group. These rules come with HTTP settings that define how application gateway interact with the backend servers. This setting includes encryption settings, such as whether the traffic between the application gateway and backend server should be encrypted. Session stickiness, for directing all requests from the same session to the same backend server. Connection draining, to gradually remove a server from the pool during maintenance to avoid interruptions. Request timeout period, to ensure stable connections. And health probes. Health probes play a crucial role in determining which servers in a backend pool are available for load balancing. To check server health, the application gateway sends a request to each server using a health probe. If a server responds with an HTTP status scores between 200 and 399, it is marked as healthy and ready to handle client request. If a custom health probe isn't configured, application gateway uses a default probe with a 30-second timeout period to decide if a server is unresponsive. Health probes help ensure that traffic is never sent to the non-responsive or failed server in the backend pool and direct traffic only to healthy endpoints and improve application reliability. Another component is load balancing in application gateway itself. Azure Application Gateway uses layer 7 load balancing, which means it balances traffic based on more than just the destination IP address. It considers higher level routing parameters like host names and path defined in your routing rules. This is a key advantage over the other load balancer like Azure Load Balancer, which works at layer 4 and balances traffic based solely on IP addresses. Application Gateway uses a round-robin mechanism to distribute client requests across the servers in each backend pool. Additionally, session stickiness ensures that requests from the same client are directed to the same server, which is important for maintaining continuity in applications like e-commerce, where a transaction shouldn't be disrupted by switching servers mid-process. Another component of Application Gateway is Web Application Firewall, which is called WAF. To further enhance security, Application Gateway includes an optional Web Application Firewall. The WAF acts as a first line of defense by inspecting incoming requests before they reach your application. It checks for common web application vulnerabilities based on the Open Web Application Security Project called OWASP top 10 threats such as SQL injection, cross-site scripting, HTTP request smuggling, remote file inclusion, and many more. The WAP utilizes core rule set that are continuously updated to reflect evolving threats. The default core rule set version is 3.1, but you can choose different versions such as 3.0 or 2.2 based on your needs. WAP can also be customized to focus on specific types of attacks and set limits on messages size to prevent large uploads from overwhelming your servers. Another component is backend pools. The backend pool is where the actual web server resides. It can consist of virtual machines, a virtual machine scale set, Azure App Service, or even a collection of on-premise servers. The load balancer in Application Gateway distributes the requests across the servers in the backend pool. When configuring backend pools, you specify the IP address or names of the servers. It's important that all the servers in a backend pool are configured similarly in terms of their security settings. If you are using TLS SSL encryption, the backend pool will have HTTP settings and reference the certificate used to authenticate the servers. The application gateway re-encrypts the traffic using the certificate before sending it to the server. For Azure App Service based backends, you don't need to manually install certificates. Azure manages the encryption between application gateway and app service and ensure that all communications remain secure by default. To summarize, Azure Application Gateway provides a comprehensive solution for managing web traffic securely and efficiently. Through its load balancing capabilities, web application firewall, and backend pool management, it ensures that your web application can handle a high volume of traffic while remaining secure and resilient to common web threats. Whether you are using TLS or SSL, dealing with e-commerce sessions, or safeguarding your servers from potential vulnerabilities, Azure Application Gateway offers a robust infrastructure that adapts to your needs. Together, these components allow Azure Application Gateway to manage and secure incoming web traffic effectively, which makes it an ideal solution for distributing, securing, and scaling web applications.